Okay, so we spent the past couple days talking about different ways to prove congruent triangles. First day we talked about side angle side. Yesterday we looked at side 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 and hypotenuse leg. Today we have our last two. Can anyone tell me what they are?
Angle side angle.
Angle side angle. Angle angle side. Okay? So we're going to walk through just specifically what each of those mean, even though I think we probably have a good idea, and then we'll go over some examples. Okay? So first one is angle side angle. Says that if two angles and the included side, we've talked about an included side before. What does that mean? The included side would be between what? The two angles. Okay? If it's not between the two angles, it's not included, right? So if two angles and the included side of one triangle are congruent to two angles and the included side of another triangle, then we know the two triangles are congruent. Right, so just as our reminder, AB is our included side. Wait, I cannot write on this today. So just like when we did side angle side, and we had to have the included angle, the angle that was between the two sides, angle side angle is the exact opposite. The included side has to be between the two angles in order to be angle side angle. Okay, so somebody tell me what parts here do we know? Let's go in order. Angle, side, angle. So what's the first angle we know is congruent? A congruent to angle X. Okay, what about the side?
AB,
Congruent to XY. And then the last angle, angle B is congruent to angle Y. So, since that is true, we can say triangle ABC is congruent to what triangle? XYZ. Okay? Everybody okay with that one? All right. Last one for today. Angle, angle, side. Says if two angles and the non-included side means it can't be between the two, because if it was between the two angles, we would be still doing angle, side, angle, right? So two angles and the non-included side of one triangle are congruent to two angles and the non-included side of another triangle, then the two triangles are congruent. So my non-included side is here. Is that the only non-included side? No, it could, right? You could have this one, would also work if we didn't have that side, okay? It just cannot be the one between the two angles, okay? So again, let's go in order of angle, angle, side. What's the first pair of angles we know are congruent here? So angle A is congruent to angle X. What's the second pair of angles? C is congruent to angle Z. And then the side that's congruent, side CB, congruent to side ZY.
Does it matter? Do you need to start like at point C, or could you start at point B?
No, yeah, you could say BC and YZ, yeah. Remember, sides don't matter. You can put either point first. Okay, so we can say triangle A, I'm going to do ACB, congruent to what triangle?
X, Y, Z.
XZY, yeah.
Yeah. Oh, and B.
I know, I switched it up on you. I went ACB, seeing if we were paying attention.
I wasn't.
Got it there, okay? All right, so not too bad, yes? can I be truthful with you? I think the only two things we haven't talked about are angle, 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 right? Just because I have three angles congruent to another. We didn't talk about that. And then angle, side, side. Okay? So those are pretty much the only two ways that we didn't talk about to prove congruence. Yes, we all know. Okay? That's why we can't use it. No, that's not really a reason. But, okay, so pretty much every other way goes. Or the opposite, side, side angle, right? Okay, so let's go through. Now, today's asks us specifically for what two proofs of congruence.
ASA,
So even though it could be what we talked about yesterday, we're not asked for that on this. We're only looking for angle, side, angle, or angle, angle, side. Now, before we start, just like we did yesterday, what things did we have to mark first? Yes. So don't forget to mark shared side and vertical angles.
Are we doing this on our own?
Is there one that's gonna be mine?
It's possible, yeah. Okay, so let's talk about example one. ASA or AAS?
AAS.
Yeah, right? We have angle, angle, side, angle, angle, side. Okay. AIXA, what about number two? Angle, side, angle, right? That side is between the two angles, so angle, side, angle. Macy, what about number three? So you can kind of ignore this one for now and just look at that. What are the markings that we have here? What's this called? Angle.
Is it angle, side, angle?
Yeah, right? Because we have angle, side, angle on the first one, then we have angle, side, angle on the second one. Okay. Rowdy, what about number four? Again, just before you go, Rowdy, sometimes it's easier to like kind of cover up one triangle and look at what you have.
It's angle, angle, side.
Angle, angle, side. Good. Because that side is not between the two angles. Okay. Symphony, what about number five? None. Now, is it actually something?
Yeah.
Yes. What is it?
Side.
Side, angle, side, right? But it didn't ask us for that, so we're going to say none. Okay. And then, Kyler, what about example 6?
Angle, angle, side.
Okay, so look here. If I cover this one up, what do you notice is between the two angles?
Side angle.
Yeah. So angle, side, angle. Here's the deal, you guys. I would always check angle, side, angle first because that side is going to be between the two angles. And if it's not, then it's angle, angle, side. Okay? All right. Just like we did yesterday, we're just going to talk through what additional information we would need to know to prove these two things. Okay? So first, if AC, if this line here bisects this angle, what do I know that that does here? What does a bisector do? Splits it in half. So what do I know about each angle here? They're congruent. So I would mark these two angles congruent. What other piece of information do I know has to be true?
That it's the side in the middle.
Yes. Our shared side. Okay? Now, in order to prove angle, side, angle, what else would they have to tell us?
One and two.
Angle 1 is congruent to angle 2.
Good. Angle 1 would have to be congruent to angle 2. Okay? All right. What do they tell us on example 2? And yesterday we talked about what does a midpoint do?
Like alternate interior?
No. What is it?
It shows it like congruent.
Cuts it in half, right? So it cuts AE in half. So what do I know about each half here? They're equal, right? Midpoint or a bisector cuts something in half, okay? What other piece of information do I know for sure?
The vertical angle.
Vertical angles here are congruent. Now, I'm proving angle, side. So there's one specific angle I would have to use.
B is congruent to E.
Say it again.
Angle B is congruent to
Good.
E.
Angle B would have to be congruent to angle D. Why could I not use E and A?
Because it would be angle side angle.
Yeah, then it'd be angle, side angle. Okay? All right. We okay with it?
Yeah.
Okay.